This is the last video in the compound interest series, and we start with a question. What if the compounding period is not a full year? So you'll see a variety of different compounding periods. You may see expressions where it talks about a particular investment or perhaps a loan where it says compounded semi-annually. So that just means every half year. And what you have to think about is what's the number of times per year that the money's going to be compounded, or the interest is going to be compounded. So if it's semi-annually, that's just 2. You may also see compounded quarterly, and obviously a quarter of a year, that would be 4 times per year. Now, before we go on, both semi-annually and quarterly, you may kind of wonder, well, what is a half a year, right? A year is 365 days, so you can't really divide a half a year exactly in a half if you want to round it to the nearest day. Same with quarterly. So we're not going to worry about these little finer points. We're just going to assume that you can divide a year into 2 equal parts, or 4 equal parts, or for that matter, we're going to assume that months are all the same. But in fact, for accounts like mortgages with banks, they do pay attention to the fact that different months have different numbers of days. But we're not going to worry about that for now. So quarterly would be 4 times per year. Monthly, we'll just assume every month is the same and talk about it as being 12 times per year. And then daily, again, we're not going to worry about leap years. We're just going to say there's 365 days in a year. There are actually some specialized investments like bonds where they make an assumption of 360 days of the year. The reason for that is because you can divide that nicely into 2 to get 180, or 12 to get 30, that sort of thing. Okay, so we need a slightly different formula, and the letters that we've used so far are going to stand for the same thing. So see the previous videos if you don't recall. So A is the accumulated amount. P is the principal, just as before. But instead of 1 plus R represented an annual interest rate. We can't use that annual interest rate. What we have to use is something called an interest rate per period, or a period interest rate. And we're going to use I to symbolize that. And so what is I? Well, I, I'll just write it here. It's the interest rate per period. And we're not going to raise this to t either, because that would just be the number of years. If we have an interest rate per period, we need to have the exponent be the number of periods, and we're going to represent that with n. And so n is the total number of periods. And let's go back up to what we were looking at there to think about what the I would be for these different compounding periods. If you are compounding semi-annually, that means that the year is broken into 2 parts, and the interest rate also gets broken into 2. So we can take the annual interest rate, remember interest rates are always expressed annually, and simply divide it by 2. So that would be our I. And similar with quarterly, it would just be the interest rate divided by 4. With monthly, it'd be the interest rate divided by 12. And with daily, it'd be interest rate divided by 365. So we've got to be a bit careful when we calculate the number of periods. And if we let the number of times per year that the interest is compounded, if we represent that with a letter, let's say C, then we can say that the number of total number of periods is the total number of years, which we in the past represented with T, multiplied by C, the number of compounding periods. So let's see how this works for an example. And I'm going to use sort of straightforward numbers, but I'm going to use the same principle, same interest rate, same number of years, and take a look at the effects of different compounding periods. So let's imagine a situation where we are putting $1,000 into an account, and it has an interest rate of 5% per year. Remember, PA stands for per annum, so that's your yearly interest rate. And then the time is going to be 10 years. Okay, so we're going to compare annual compounding with semi-annual and monthly and daily. So there's semi-annual, there's monthly, and there's daily. So we already know, we've seen examples before of annual compounding, but we can use the same formula that we just developed. In this case, though, the C, the number of compounding periods, is simply 1. So when you take the interest rate and divide it by 1, you just end up with the interest rate. Same with multiplying the T, the time, by 1, you just end up with T. So we have A equal to 1,000 times 1 plus the interest rate 0.05 raised to the power of 10. For semi-annual, we're going to take the same principle, 1,000, and we're going to multiply that by 1 plus 0.05 divided by 2, raised to the power of 10 times 2, which would be 20. For the monthly, we'll have the accumulated amount equal to 1,000 times 1 plus 0.05 divided by 12, raised to the power of 10 times 12, which is 120. And for daily, we're going to have the accumulated amount equal to 1,000 times 1 plus 0.05 divided by 365, raised to the power of 10 times 365, which is 3650. Now, be very careful when you're doing these calculations with your calculator. You probably want to start with the interest rate. So let's use the monthly as an example. So you would start with 0.05, you would divide that by 12, and then you would add 1 to that. Now, depending on the calculator you're using, you could do all of that in brackets, or you could just sort of hit equals. Then you want to raise that to the power of 120, and then finally you want to multiply that by 1,000. So let's see what these all come out to, rounded to the nearest penny. The first one is $1,628.89. Now remember, if this were just simple interest, you'd be getting 5% of 1,000, that's $50 a year. Over the course of 10 years, that'd be $500. You'd end up with $1,500. So compounding annually is significantly better than simple interest. But let's see how much better these more frequent compounding periods are. If you punch in the numbers for semi-annual, you get $1,638.62. So it's a little better. It's about $10 better. If you do it for monthly compounding, you get $1,647.01. So it's almost another $10. And if you do it for daily compounding, you get $1,648.66. So that's only about $1.60 better than the previous one. So it looks like it's certainly better. The more frequently the interest is compounded, the better off you are. But you can see there's kind of a declining increase here. We're not going to get that much better if we go more frequent than daily. Now, back in the 1970s, apparently there was sort of competition between banks to see how frequently they could compound the interest on savings accounts to make their savings accounts look better. And so they actually did do this. They went to daily compounding or hourly compounding. There is an actual limit as to how good you can get or how high you can get if you compound more and more frequently. And you'll find out the mathematics behind that limit when you take calculus. It turns out that no matter how frequently you compound, you're never going to do better than $1,648.72 rounded to the nearest penny. So at daily compounding, you're pretty much at your limit and you're not going to do much better.